Hey guys, it's Mike from Arnold Tutoring. I wanted to provide you a run-through of the June 2018 Manitoba Provincial Pre-Calculus exam at the 40S level. I did this last year as well, and I think it really helps to show how I would take the exam. Basically, I've downloaded each booklet, and then I've just recorded myself walking through each question, what I'm thinking, how I approach each problem, and hopefully you'll find some value in that. I also always like to see what they're changing in the exam, what topics they're still focusing on, and maybe what topics they haven't put a lot of energy into. So hopefully you enjoy it. Booklet 1 immediately follows this video, and then I'll be releasing booklet 2 later. Also, please be on the lookout from your teachers, hopefully, about our Provincial Pre-Calculus Exam Prep Seminar, which we hold every January and June to help you guys get ready. It's filled with tons of practice problems, step-by-step solutions, and we go over every major topic that's needed for success on this exam. So please enjoy. Hopefully you find some value. Leave a comment if you have other questions, and hopefully we'll see you at the seminar.
Okay, question 1. Pierre pushes his car into a garage. The radius of a tire is 22 centimeters. Determine the distance traveled by his car if the tire rotated a total of 1,000 degrees. As soon as we read this, super common question, actually super common for the first one, S equals R theta, but theta has to be in radians, so I'm going to change 1,000 degrees. I'm going to multiply by pi over 180 to give the theta in radians. And we are looking for the distance traveled, so that's S with a radius of 22 centimeters times by 1,000 pi over 180. Toss that right in the calculator, and we get 383.97 centimeters. Don't forget your units. Question 2, solve algebraically. We know it's a calculator question, but we also know 7 and 85 can't be made based out of the same base. So I'm going to log both sides. I'm going to bring down the exponent when I log the left side. So it's log of 7 equals log of 85. I'm allowed to do that because we took the log of both sides. Now we just isolate for x. So it's x equals 2 log 85 by multiplying both sides by 2. And I'm going to divide by log 7 all at the same time. Toss that in the calculator. And I get 4.566. That is x. Question 3. Solve algebraically over the intervals 0 to 2 pi. Notice your domain every time. 0 is included, 2 pi is not. We're already in factored form, which we like, so we can just break that up and we can say, okay, if those two things multiply, sine x and the bracket multiply to give 0, one of them must be 0. So either sine x equals 0 or secant x plus 3 equals 0. And for this one, that would mean secant x would have to be negative 3. Where does sine x equals 0? We should know that without a calculator. That happens at x equals 0, pi, and it would be 2 pi, but 2 pi is not included because of the round bracket, so do not include 2 pi there. Now where does secant x equal 3, or negative 3 I should say? Well, that's where cos x will be the reciprocal, is negative 1 over 3. And how do we do this? We always want to input it in our calculator. We want to take the inverse of the positive, so we ignore the negative 1/3 to get our theta 0, or our related angle. So I'm just going to pop that into the calculator, 1/3. And that gives, I want to go into radians. 1 divided by 3. We also need to realize that 0 to 2 pi, that's in radians, so make sure your calculator's set to radians here. So the inverse cos of 1/3 gives radians of 1.231, but that's not an answer. We want x in quadrant 2 and 3 because that's where cosine is negative. Notice cosine was negative 1/3, so in quadrant 2 it's going to be pi minus 1.23, and in quadrant 3, where the other spot where cos is negative, it'll be pi plus your related angle, 1.23. So if I do plus pi, so this one I get 4.373, and quadrant 2 I will get, just fiddling around with the calculator here, I want to make that negative. So I will get 1.911. So those are your 4 answers for X, these 2 blue ones and these 2 red ones. That one's worth 4 marks, so definitely worth the time and making sure you get that right. Alright, Brahim invests $2,500 at an annual interest rate of 6.75% compounded monthly. Determine algebraically how many years it will take for his investment to reach an amount of $10,500. They even tell you the formula and what each piece means. Let's key in on what they're asking for, how many years. So that must mean we are looking for T, the length of the investment in years. Let's use this formula and plug in everything that we know. A is the amount after T years, so we want that to be 10,500. The principal is the starting amount, so 2,500. And an annual interest rate of 6.75% compounded monthly. So that means 12 times per year. So it's going to be 1 plus 0.0675. Make sure you use the decimal form. Over 12 times 12t. So the t is what we're looking for. So I'm going to use algebra to first divide by 2,500, both sides. That will cancel it on the right. And we can do the 0.0675 divided by 12 and add that to 1. So we get 1.005625 to the 12t. We can do 10,500 divided by 2,500, and we know that's 4.2. So we have 4.2 equals 1.005625 to the 12t. And this looks a lot like one of those exponential questions, so we can just go ahead and log both sides. So I'm going to take log of 4.2 equals, then the exponent can come down, 12t log of 1.005625. And to solve for t, we just divide everything. So on the left side, I am going to have log of 4.2, and we're going to divide that by 12 times the log of 1.005625. That will leave me, if I do that on both sides here, 12 log 1.005625, that will cancel with that log, the 12 will cancel, and that's why we're left with the t. Plug that into the calculator, and where will I leave the answer? I'll leave it right here. T equals, so 21.32. So I get 21.32 years. They don't really ask, I guess they want it in years, so you could round that. It will take 22 full years to surpass that amount. 320 would be the third decimal. So 21.32 years, and that's because it's actually compounded monthly, right? So there will be fractions of the years, but if they asked for it, if they wanted it rounded to, how many years, whole years will it take for that investment to reach 10,500, it wouldn't happen until the 22 years are technically over if we're rounding to whole years. You can't round down to 21 years because you haven't quite reached that amount yet by then. All right, another calculator question. 13 adults, 18 children who can be selected to go on a trip. Determine the number of ways 4 adults and 7 children can be selected. If Sandra, one of the adults, must be selected. So let's deal with Sandra first. There's 13 adults. 1 is Sandra, so you can think of it as 1 choose 1. Sandra has to be chosen. And then from the other so we're going to multiply, and from the other 12 adults, 3 need to be chosen, any of the 3. And you need to choose 7 children from 18, so 18 choose 7. And it's literally as easy as that. 1 choose 1 is just 1, so we don't have to worry about that, which makes sense. From the other 12, you have to choose 3 adults. From the 18 children, you have to choose 7 children. Pop that in the calculator. And you get 7 million ways, basically. 7,001,280 ways. That is a lot of ways, but it makes sense. You got a huge group, and you're only choosing a few from them, so there's going to be a bunch of different ways to do it. Question 6, binomial expansion. Determine and simplify the 6th term. Well, we have a formula for this. The way I always do it is I take the full exponent, so out of the 9, I'm going to choose 5, 1 less than the term that we're trying to find. Then I copy the 2 terms that are part of the binomial, so it's x cubed, and I put that 5 as the exponent. Whatever is here, that has to match the exponent on the 2nd term, and the exponent on the 1st term has to add up to 9 along with the other exponent. So if 5 is at the back, 4 has to be there because 4 plus 5 equals 9. And that's really it. Now we just use our calculator to simplify. So what's 9 choose 5? That's 126. So 126 times 2 to the 4. So that's 16. 2 to the power of 4 is 16. Over x to the 8. Make sure we multiply the inside exponent with the outside exponent. And same thing here, a negative raised to the power of 5 is going to give another negative, and it's going to be x to the 15. Again, multiply exponents on the inside and outside. Now we can just deal with numbers together and then exponents together. So 126 times 16 is 2016, and we have a negative, so it's definitely going to be negative up front there. X to the 15 on top, x to the 8 on the bottom. We subtract exponents, so we're left with negative 2016 x to the 7, because 15 minus 8 is 7. There we go. That's simplified. Question 7, we're off of calculators now. Evaluate f of 0. Whenever we have function notation like this, we always start from the inside. So f of 0 means the y value whenever x is 0. So if I go and look at my points, when x is 0, y is 2. So I now have, instead of f of 0, I know that f of 0 is 2, so I now have f of 2, which means go and find the y value when x is 2, which is 4. Perfect. One quick mark. I'm going to change to orange here. The point negative 5 over 6, b is on the unit circle and in quadrant 3. That's helpful. Determine the exact value of b. So we're in quadrant 3, which means x and y are both negative. So I know b is going to be negative. That's all we get from the quadrant 3 part. To know that it is on the unit circle, that means the coordinates squared and summed have to equal 1, right? We know that the radius of the unit circle is 1, so any point on the unit circle, if we're down here, we can take the x and the y, square them, and we get 1 squared, right, because of Pythagoras. So I'm just going to do that. I'm going to do negative 5 over 6 squared plus b squared, it'll actually be negative b squared, has to equal 1 because of Pythagoras. So 25 over 36 plus b squared has to equal 1. B squared has to equal 1 minus 25 over 36, which equals, if you get a common denominator, that's 11 over 36. So b squared equals 11 over 36. Then b has to equal plus or minus the square root of 11 over 36, which is plus or minus the square root of 11 over 6. Perfect. And we know, like we said before, it's negative, so b equals negative root 11 over 6. Row of Pascal's triangle to determine the values of the next row. Super easy. All we do is sum the two values. We hit all of the gaps, and we sum the two values above each value. So I'm going to start with 1 on the outside, because you can imagine there's sort of like a fake 0 there. So 1, and then 1 and 6 gives you 7, 6 and 15 gives you 21, 15 and 20 gives you 35, 20 and 15 gives you 35, and it just works its way down back to 21, back to 7, and then 1 on the outside. So this is the whole row. Easy 1 mark. Following transformations are applied to f of x, resulting in a new g of x. State the equation of g of x in terms of f of x. So notice how they've done that. They said g of x equals something, and in terms of f of x, that means f must be in our function. That actually is going to be part of our answer. So a reflection over the x-axis, that means a negative out front. So I would think of it as like negative f of x, like that. A vertical stretch by a factor of 3. So now instead of just the negative out front, I now have negative 3 f of x, because vertical stretch is outside. And a horizontal stretch by a factor of 4. So the common mistake would be to say, oh, that's 4x, but that would be a horizontal compression. So instead of that, we have to flip it in the x, so it's x over 4, or 1/4 x if you like either one of those. And that's your function. G of x equals negative 3 f of x over 4. There's the reflection over the x-axis, there's the vertical stretch of 3, and there's the horizontal stretch of 4. Very easy 3 marks. Given the graph of f of x, sketch the graph of y plus 1 equals to, okay, so this is a pretty tough question. First of all, the y plus 1 is no good, so we want to get y on its own in terms of f of x. Very similar to the last question we just saw. So it's going to be 2f of x minus 3 minus 1. Now let's just categorize all of these. This is a vertical stretch by 2, factor of 2. This is a horizontal shift, right 3, that's this guy here, the x minus 3, and then shift down 1. So literally just do all of that with all of the main points. So the best way to do this on the exam, you can see the 4 main points are sort of highlighted. I would do that with all of them. So a vertical stretch of 2, so these points at 1 go to 2. And then right 3 and down 1. See if we can zoom in here a bit. There we go. So vertical, I'm going to start with this far left point. Vertical stretch to 2. Shift it right 3, 1, 2, 3 onto the y-axis, and down 1. So that point actually ends up on top of where the other point was. Same thing with the y-intercept that we had. I'm going to shift it up to 2, or stretch it up to 2, sorry, because it's at 1. 1 times 2 is 2. Shift it over 3 and down 1. So that ends up being right here. Right, so we've already connected that way. Now I'm going to focus on this bottom point here. the y value there was -2, so I've got to vertically stretch that by a factor of 2, so it becomes down to -4. Then I'm going to shift it right 3, 1, 2, 3, and down another one, so we end up over here. Great. Can connect that. And then lastly, we're going to adjust this x-intercept point. That's at the point 3, 0. So the vertical stretch has no impact because 0 times 2 is still 0, but it's going to shift 3 right and 1 down. So 1, 2, 3 over, 1 down. It'll end up right there, and there's our function. Pretty straightforward. Another nice trick is you can always do point mapping. So if any point had coordinates x, y on the original, the new one will have x over b plus c and ay plus d when you think about the vertical and horizontal stretches and the vertical and horizontal shifts. Moving along, state the equation of the horizontal asymptote of f of x. Quick little trick, you look at the degree of the top, degree of numerator, and that just means the highest exponent on x, so in our case it's 2 because we have an x squared on top, and the degree of the denominator, or whatever's on the bottom. That's a polynomial as well, and the degree is also 2. Right, there's an x squared. When those are the same, you take the coefficients. The equation of the horizontal asymptote will be the coefficient of the top over the coefficient of the bottom. When I say coefficient, that means the numbers in front of those of the highest x terms. So in this case, it equals 2 over 4, which equals 1 over 2. So make sure when we state the equation, it's y equals 1 over 2. Given that x plus 4 is one of the factors, express p of x in completely factored form. Perfect. When they tell us x plus 4 is one of the factors, that means x equals -4 must make p of x equals 0. In other words, p of -4 must equal 0. So I'm just, which is great, right? But what we want to do is find the other factor. So I'm actually going to divide out. I'll use long division in this case, but you could use synthetic if you prefer. X cubed plus 6x squared. I'm going to add a plus 0x in there and then a minus 32. This just helps me keep everything in line so that we're not skipping any terms, right? We don't want to go right from x squared to the number because it'll look like we've missed one of the terms. So x into x cubed goes x squared times. Multiply that back down, we get x squared plus x cubed plus 4x squared. Subtract, and we get 2x squared. Now you repeat the process. X into 2x squared is plus 2x times. Multiply it back down, bring this plus 0x down. Multiply it back, and we get 2x squared plus 8x, because the 2x is getting multiplied to the 4x. Subtract again, and we get minus 8x. Bring down the minus 32, and x into negative 8x is negative 8 times. Multiply it back, we get negative 8x minus 32, and that leaves a remainder of 0 when we subtract, which should happen, right? We were told x plus 4 is a perfect factor, so it should factor out. So I now have p of x equals x plus 4 times x squared plus 2x minus 8. That's the quotient on top. And I make sure we can factor that further. Px equals x plus 4. This is an easy quadratic to factor into x plus 4 and x minus 2. So that's the fully factored form. You could also write this as x plus 4 squared and x minus 2. Hopefully that wasn't too fast. This should be pretty simple quadratic factoring, and the long division, again, you could use synthetic if you prefer. Question 14, proven an identity for all permissible values of theta. That just means whenever we present our solution, it will be implied that we're only dealing with numbers that don't make denominators 0. This is pretty tricky. You could start with either side. I'm actually going to start with the right side, mostly because of the 2 theta on the bottom. So everything else on the left side is just dealing with theta. So I'm gonna use the right side, and I know that sine 2 theta is 2 sine theta cos theta over tan theta minus 1. Again, this way everything's in terms of theta, so we're already in better shape. And then, as always, we want to look at sort of where we're at. I think that's a really helpful strategy to say, okay, am I where I need to be able to get to the left-hand side? Well, right now we've got a sine theta on top, but we only want to end up with cos theta on top, right, if you look at the left-hand side. However, we have tan theta minus 1 on the bottom, and I want to get to 1 minus cotan theta. Those almost sound the same, but they're a little bit off. So what are we going to do? Let's keep working on the right side. We can't really do anything with the top right now. But what if we changed tan theta to 1 over cotan theta minus 1? And the good thing about doing this is that I know I want to get to 1 minus cotan theta, and I can do that now by multiplying. I don't like fractions in fractions, so if I want to get rid of that, I'm going to multiply by cot theta over cot theta. And the beauty of this is that we'll get 2 sine theta cos theta on top times cotangent theta. So I'm actually going to change that cotangent theta to be cos theta over sine theta, because that'll get rid of the sine theta that I want. And if you multiply the cot theta in on the bottom, you'll get 1 minus cotan theta, which is perfect. My bottom matches the bottom of the left-hand side. I'm just going to, normally I'd have more room, but I'm just going to move it up here. Now we can show that this sine theta cancels with this sine theta, so we're left with 2 cos squared theta on top, 1 minus cotan theta on the bottom, so we can say left-hand side equals right-hand side. I didn't even have to touch the left-hand side. This is more a case of, can we force in what we need on the right to match the left? So I knew I had a tan theta here on the bottom of the right, but I wanted cotangent theta, so I wrote tan theta in terms of cotan. Remember that tan theta equals 1 over cotan theta. That's a helpful one to remember. Restaurant A has 5 types of hamburgers, 2 types of french fries, 10 types of drinks. Restaurant B, 4, 5, and 6. A meal is made up of a hamburger, french fries, and a drink. Which restaurant offers a greater variety? Okay, so this is simple factorials. We're going to do not factorial, sorry. I would do the slot method here. So restaurant A, how many combos are there? There's 5 times 2 times 10, which is 100. We can do without a calculator. And same thing, hamburgers, fries, and drinks. 4, 5, 6. You can think of this as, I'm just writing 4, 5, and 6, but it's really 4 choose 1 times 5 choose 1 times 6 choose 1. It's the same thing. And this gives us 120. So this justifies that B has more variety. (16) expresses a single logarithm. Log rules tell us that we can't do anything with this first logarithm. Terms inside subtracted don't do us any good, but when we add logs, we'll be able to combine those. Plus, this 2 as an exponent, as a coefficient in front, can be written as an exponent on the term inside. So this is 3 squared. I just moved that 2 on top of the 3. This gives us log of 7. 2x minus 5 plus log of 7 of 9. 3 squared is 9. When we add 2 logarithms of the same base, that means we can combine them into 1 and multiply the terms inside. So we get 2x minus 5 times 9. Simplify this, and we get log 7 of 18x minus 45. That is one nice logarithm. Explain why 11 factorial is not the total number of 11 letter arrangements that can be made from the word celebration. Well, explain they don't really want any math here, so we just have to write out something like because E, the letter E, and are there any other letters that repeat? No, it doesn't look like it. Because E is repeated, I would say something like switching the position of the two E's does not create a unique arrangement. So there will be less than 11 factorial ways despite 11 letters in the word. Right, so they're trying to get us to recognize we know our formula is n factorial over a factorial, b factorial, c factorial whenever anything repeats, and that's what happens. As we divide that out, it reduces the number of combinations. So hopefully that was helpful. It was fairly rushed, but 30 minutes to get through 17 questions, that's not too bad. Obviously you want to go back over and check your work, but hopefully you found this helpful, and you can see I'm always kind of keeping an eye on the marks for each question too, because that can dictate whether you're maybe going down the wrong path. If it's only a 1-mark question and it's taking you a while, usually the marks are very consistent with how much time it should take you. Thanks so much.